These are the values of root 2 and root 5, which are accurate to the 5th or 9th decimal place. You can calculate in just 3 steps. Here is a very easy and quick method to calculate the square root of any number as accurately as you want. Let's math travel to the method and its principles. We are going to calculate root 5 first. 5 lies between 4 and 9, between 2 squared and 3 squared. 2 is the largest integer, smaller than root 5. So root 5 is equal to 2 plus k. K is greater than 0 and less than 1. Let's express the first approximate value of k as a fraction. Only 2 numbers are needed, 2 and 5. The numerator is 5 minus 4. 4 is the square of this 2. The denominator is to multiply 2 by 2. This 2 is this 2. Since k is a quarter, root 5 equals 2 plus a quarter, 2.25. This is the first approximation of root 5. If you are curious about how to derive this value, please watch the related video. The square of the first approximation is 5.0625, with an error of 0.0625 from 5. Now, let's reduce this error. The second approximation can also be expressed as a fraction. The numerator is the square of the first approximation plus 5, 10.0625. The denominator is first approximation times 2, 4.5. The second approximation is 2.2361. The square of this value is this. The error from 5 is only about 0.0001431. To reduce the error even further, repeat the same process. The numerator is the square of the second approximation plus 5. The denominator is the second approximation times 2. The third approximation is this. The square of this value is this. It's getting closer to 5. In fact, root 5 is this. Compare this with the third approximation. It's accurate to the 9th decimal place. It's incredible how such an accurate value can be achieved in just 3 steps. Let's explore its underlying principle. To learn the principle of calculating the first approximation, please watch the related video. The first approximation is 2.25. Its square is 5.0625. This is the graph of y equals x squared. Finding the square root is equivalent to finding the x value in y equals x squared. The x value for y equals 5 is root 5. Since the square of 2.25 is greater than 5, it is here. This error is 0.0625. The x value is also greater than root 5. This is the margin of error. To find a more accurate approximation, we draw a tangent passing this point. The intersection of this tangent with y equals 5 provides a new point. The x value of this point is closer to root 5 than the first approximation. This is the second approximation. Let's calculate it. Differentiating y equals x squared gives y equals 2x. This function represents the slope of the tangent at each point. Substituting the first approximation, 2.25, into the equation, y equals 4.5. This is the slope of this tangent. Since the tangent passes through this point, its equation is as follows. Substitute y equals 5 into this equation. The solution to this equation is not only the x value of this point, but also the second approximation. The numerator is the square of the first approximation plus 5. The denominator is the first approximation times 2. X is approximately 2.2361. Its square is this. This is how we get the second approximation using the equation of a line. By repeating this process, you can find a more accurate third approximation. The numerator is the square of the second approximation plus 5. The denominator is the second approximation times 2. The third approximation is this. The square of this value is this. The error from 5 is almost negligible. If you want the more accurate value, you can repeat this process as many times as needed. As practice, try calculating root 2. It is greater than 1 and less than 4, greater than 1 squared and less than 2 squared. It is 1 plus k. The numerator of k is 2 minus 1. The denominator of k is 1 times 2. Since k is a half, the first approximation is 1.5. The square of this value is 2.25. Let's calculate the second approximation. The numerator is the square of the first approximation plus 2, which is 4.25. The denominator is the first approximation times 2, which is 3. The second approximation is about 1.41666. The square of this value is as follows. Now, let's find the third approximation. The numerator is the square of the second approximation plus 2. The denominator is the second approximation times 2. The third approximation is 1.4142157. Compare this with the actual value of root 2. This is accurate to the 5th decimal place. Thank you.